Hello class, we're going on to 7.2.3-ish over proving a quadrilateral is a parallelogram. We will also go through ones like proving a quadrilateral is a square, a rectangle, a rhombus, and etc. But for now we're going to do proving a quadrilateral is a parallelogram, and we did go over something similar to that, or at least knowing the properties of parallelogram on 7.2. So this is kind of like your 7.3. Okay, so 7.3. I apologize, this does like to go in and out, so hold on one second. Alrighty, so the first method on showing that, proving that quadrilateral is a parallelogram is showing that the diagonals bisect each other. So if we went through the Venn diagram, you know the diagonals bisect each other. So if I had a parallelogram, the diagonals bisect each other, which means it's cut in half, so think half of it. So that means that these two are perpendicular or congruent to each other, and my other opposite sides are congruent to each other. Note they're not all the same length. And the way to show that through coordinate points is by showing the midpoint. So showing the midpoint where it's cut in half for each one of those in the diagonal. And so to remember midpoint, you know midpoint formulas where we take x1 plus x2 all over 2 for our x value, and then for our y value we add both the y coordinates together and divide it by 2, and that is our midpoint. Okay, the second method is to show that the opposite sides are parallel and have equal slopes. So they're parallel with equal slopes. Okay, so parallel means they have same slope or equal slope, so we're just showing that these two are parallel to each other, and then my sides are parallel to each other as well, as what it says, parallelogram. Our third method is showing that the opposite sides are equal by using distance. So there's two ways you can do distance. This is showing that these are the same distances as the other sides. And to show distance, you can use distance formula, or we can use the Pythagorean theorem. And I'm going to put Pythagorean theorem on here because that one's usually the easiest to do. But if you prefer distance formula is kind of like an elongated version of the Pythagorean theorem. So that's where you have x2 minus x1 squared plus the difference y2 minus y1 also squared. But again, the Pythagorean theorem is still a squared plus b squared equals c squared. And you will see this more often when we're going to do the example. You'll see how this might be beneficial for you. I also forgot about slope. Don't forget slope in y equals mx plus b. M stands for the slope. Remember that is rise over run. So you can count, especially if you have a graph. Or your point is y2 minus y1 and x2 minus x1. So midpoint formula, slope, and Pythagorean theorem or distance formula is going to help you out a lot. And then for number 4, it just shows one pair of sides both parallel and equal. That's pretty much method 2 and 3, so we'll actually be showing all 3 of really this evidence, and number 4 is kind of just verbatim given to you. So let's go on to our first example. It's proved that the quadrilateral with these coordinates is a parallelogram. So the first thing we're going to do is we're going to plot our points. So L is -2, 3. And please pardon the Band-Aid. Had a little accident earlier, but I'm okay, so we're all good. So M is 4, 3. N is 2, -2. And O is -4, -2. So here is our parallelogram. Alrighty, so let's go through method 1, and that's to show the diagonals bisect each other. So the diagonals bisect each other. That means we have these dotted lines going from the opposite sides to the other. And we have to show that by using midpoint formula. So remember, to show the midpoint, you're using x1 plus x2 all over 2, and then y1 plus y2 all over 2. And we have to show this for the diagonal point. So we're doing this for MO. Let's do MO first. So MO, M is 4, 3, and O is -4, -2. So we're doing our x values first. So I have 4 plus a -4 all over 2, and our y is 3 plus a -2 all over 2, and simplified, 4 plus the -4 is 0 over 2, and 0 over any number is just 0. And then I have 3 plus a -2, which is really just 1. So I have 1/2. So that's my midpoint. Now I'm going to do the same thing for LN, because that's my diagonal. So L is -2, 3, and N is 2, -2. So for our x values, I have -2 plus 2 all over 2. And then for our y values, I have 3 plus a -2 all over 2. And simplified, -2 plus 2 is just 0. 0 over any number is just 0. And then 3 plus -2 is same as 3 minus 2, which is just 1. And I sell that half, or that 2, so now it becomes 0, 1/2. And these are the same, so they intersect at the same point. So that means this checks off. Method 1 works. So our next method to show that this is a parallelogram is to show that the opposite sides are parallel by equal slopes. So the best way to do this one is you can always use rise over run. So for method 2, so this is method 1. So now we're on to method 2, and that is using slope. And you're going to find the slope of the opposite side. So we have to do it for LM here, and then we have ON. ON is parallel to it. We have to show it parallel by the slope. And then we have MN and LO. Okay. So showing pair sides of equal slope. So the slope of any horizontal line is just 0. So that should kind of be memorized given it's from Algebra 1. Horizontal lines have a slope of 0. So that means LM's slope is 0. And then ON, that slope is also 0. And then MN, again, you can do rise over run. So let's see, how far did I walk? 1, 2, and then went up 1, 2, 3, 4, 5. So 5, and then I walked over 2. So remember, it's a rise over run. So I did 5, because y value I rose, and I went over 2. Okay, and I can also do the same for the other side. And note is a positive slope because the line is increasing. And I'll do the same for the other side. So I walked over 2, then went down 1, 2, 3, 4, 5. So that's 2, and that's a 5. Again, rise over run, so my slope is 5/2. So I showed that these lines are parallel because they have equal slopes. So these are parallel to each other based on the slopes. Alrighty, so we're checked off on that one. And so then our third method says to show the opposite sides are equal using distance. Now you can always plot in your points, but you can also use the Pythagorean Theorem, and this is how you can use it. You know how we counted slope? We did 5, 2. Doesn't that look like a tiny triangle? So if I were to just shade in this part, I have a right triangle that I counted with 5 and 2. And all I need to find is my hypotenuse, or the slanted line, to find this distance. So I need to find the distance between LM, ON, MN, and LO. So since we've already started on this one, we're going to talk about LO down here at the bottom. So we counted at 5 or 2, that's a slope. But how do we find the distance? Well, that's just how we can use Pythagorean Theorem. So I have a squared plus b squared equals c squared. And c squared is definitely my longest side. A would be 5 squared. B is 2 squared. And I need to find c. So I have 25 plus 4. And so I have 29 equals c squared. And do not forget, absolutely do not forget to make sure you square root both sides, because I want c, not c squared. So that means c is the square root of 29. So it means the distance of LO is the square root of 29. So if we do our math correctly, we still have 5 and 2. Again, it's like a small right triangle on this side for MN. And we're trying to find this part. So you're still using Pythagorean Theorem, and plus we already know this one because, you know, it's the square root of 29. So, but make sure you check it. The whole point is to show the evidence. You can't just assume because it might be off by a little bit. So we know for MN it is square root of 29. To find the distance of LM and ON, you don't have to use distance formula for this because it does make a straight line. Another way we talked about this is by jumping. So we can always count the distance all the way across. So from L to M, we have 1, 2, 3, 4, 5, 6. So LN has a distance of 6. And ON has a distance of 1, 2, 3, 4, 5, and 6. So the distances on the opposite sides are the same. So now we've given all of our, now we've given all of our information. We've done all the math. We've shown the midpoints, the slopes, and method 3 was the distance. And no, we don't really have to show both pairs are parallel and equal because we kind of did that using slopes and distance. So this is the evidence, the main thing that you want, evidence. So in conclusion, for the first method, we showed the midpoint of the diagonal. So when you want the midpoints of the diagonal, all you're doing is kind of simplifying your answers. So you have 0, 1/2, and 0, 1/2 for our midpoints. So this is for the midpoint. The next part of our evidence was the slope. So because LM and ON have the same slope, they're parallel to each other. So then you would say LM is parallel, that symbol means parallel, to ON. And then we say the same thing for MN and LO because they have the same slope. So MN is parallel to LO because they have the same slope. Okay? And then for our last piece of evidence, we're showing the distance. And when we're showing the distance, that we're showing that what's congruent to each other. So which two are equal to each other? That would be LM and ON. So I'd say LM is equal to ON. And then MN is equal to LO because they have the same distance. So congruent, same number. But for slope, remember showing they're parallel or perpendicular. So remember, we might hit perpendicular ones later, but in this case, we want to know that they're parallel. So that is showing the evidence of proving a quadrilateral is a parallelogram. So let's see if we can do another example on a different page. Okay, if you go to page 17, there's another example on proving a quadrilateral is a parallelogram. So we're looking at coordinates P1, 2, 4, 5, 6, and 5, 3, and we're trying to prove it's a parallelogram. So let's graph our points. So P is 1, 1. Q is 2, 4. Then I have R is 5, 6. And S is 4, 3. Well, here's our parallelogram. So now this one's going to be a little bit tricky trying to figure out our distances and things like that. So we know we need to do 3 methods. So method 1 is the midpoint. Midpoint of the diagonals. Okay, so remember midpoint, you're doing x1 plus x2 all over 2, and then y1 plus y2 all over 2. And so let's do QS, and then we have RP. So QS, we're taking our x coordinates of Q, so I have 2 plus 4 all over 2. And then for S, the y values of Q and S, you have 4 plus 3 all over 2. So you have 6 over 2 and 7 over 2. Okay? And you can always simplify. 6 over 2 is the same as 3. So I have 3 and 7/2. We're going to do the same for R and P. So R is 5 plus 1 all over 2. And then for our y values of R and P are 6 plus 1 all over 2. So I'm left with 6 over 2 and 7 over 2. And I'm left with the same answer. So 3 and 7/2. So I know this worked. My diagonals have the same midpoint. So method 2 is finding the slope. So we have to find the slope of each side. So I have PQ, QR, RS, and SP. Remember, you're doing rise over run, or you can use the formula. So let's do rise over run. So for P and Q, I rose 1, 2, 3, and I went over 1. So when you rise, over your run. So I have 3 over 1, which is the same thing as 3. And then for QR, I went up 1, 2, and I went over 1, 2, 3. And then for RS, I went down 1, 2, 3. So you rise over your run. And I walked over 1. So my slope is still 3. And then for SP, I walked over 1, 2, 3. And I rose up 2. Alrighty, so that is finding our slope, and we're going to go back to giving our evidence momentarily. Let's do our method 3, which was our distance. And this is where you're using that Pythagorean Theorem. So think a squared plus b squared equals c squared. Having those perfect little triangles. It makes it a lot easier than doing the distance formula. So we still have PQ, QR, RS, and SP. Alright, so I'm going to write them out to the side here. So let's say we're doing PQ. So we said that we rose 1, 2, 3, and went over 1. So we have a triangle that looks like this, 3 and 1. And when we're trying to find C value here, the distance. So I have 3 squared plus 1 squared is C squared. So I have 9 plus 1 and 10. Make sure you take the square root of both sides. So C equals the square root of 10. So PQ is the square root of 10. So we're going to check. We should have the same thing for RS. Should have square root of 10. Maybe double check me. I could be wrong. So let's do QR. So remember, I rose up 2. So if I do a small triangle here, for Q and R, I rose up 2, and I went over 3. Trying to find this value here, so I have 3 squared plus 2 squared equals C squared. So that's 9 plus 4, and 9 plus 4 is 13. So I have 13 equals C squared, and make sure you take the square root. So C equals the square root of 13. So I'm kind of shortcutting here. You can always give all of your math because you never know, this might be slightly off. And if your numbers are off, that means it's probably not a parallelogram. So now we've done all 3 pieces of our work. So now we're going to get the evidence part. So your evidence, you found your midpoint. So we have our midpoint of the diagonal. Remember, this is talking about the diagonals. Is 3 7/2 and 3 7/2. Okay, and so remember that was for QS and RP. And then our slope tells us if something is parallel or perpendicular, so don't forget that. So think slope, parallel, or perpendicular. In this case, we want them to be parallel for a parallelogram, hence its name, parallel. So if they have the same slope, then they're parallel to each other. So that means PQ is parallel to which one? Which one has the same slope? That would be RS. And then QR would be parallel to SP. Awesome. And remember, distance, our last piece of evidence, shows us congruency or equal. So which two are equal to each other? Well, PQ is equal to RS and SP is equal to QR. And so that is our evidence to proving that a quadrilateral is a parallelogram. And so throughout this packet, you might find some more in here. There's ones where we're going to prove something is a square, a rhombus. And so for your practice, see if you can try number 3 on page 18. So number 3 on page 18. See if you can try number 3. It's prove that quadrilateral, the coordinates is a parallelogram. So if it also helps, you can always draw a box. Always draw a box. And then you can always label one part as slope and distance. And you can put midpoint over to the side if you want to of your diagonals. And then you can label your points. You can always say RS, TU. Oh, after you plot them, let's plot the points first. I'll get you this far. So you have 3, 2. S is 6, 2. T is 0, negative 2. And U is negative 3, negative 2. Alrighty, so let's see if you have what it takes. Oh, I think I've plotted one wrong. Let's look at U. U is negative 3, negative 2. And negative 3, negative 2 is over here. Ha! And that is okay. It's alright to make mistakes. As long as you know how to fix them. So I have 3, 2, and then U is negative 3, negative 2. Then I have T is 0, negative 2. And then S is 6, 2. So this is definitely your parallelogram. Pardon the off colors here. So here's your parallelogram. So you have to find RS, TU, RT, oh, I'm sorry, not RT, RU, and TS. So maybe find the slope and the distance for each one. This would be great practice. Thank you so much.